In this question, we're asked to calculate the amount of work done by a mixture of helium and oxygen that expands from 19 liters to 21 liters at a pressure of 26 atmospheres. So what we need to do is know a couple of formulas. First of all, work, W, equals negative P, pressure, in atmospheres, delta V, change in volume, delta means change, volume, in liters. And it's also important to note that delta V equals Vf, the final volume, minus Vi, the initial volume. However, when it comes to thermodynamic questions, the sign is very important. If it's positive, that means that work is done on the system. If it's negative, it means the system does work. And we can figure that out before we even do any of the math. And it's always important to double check whether you get the negative or the positive answer based on what's actually happening, not necessarily just based on the math. Because remember, there can't be negative work, all right? It can't actually be like opposite of work. What it means is work done by the system. So if work is negative, that means the system did the work as opposed to the surroundings doing the work. So in this case, if a piston expands from 19 liters to 21 liters, it means the system did work. So we know that this answer is going to be negative. We can make sure the math works out, but it's also a good idea just to double check that we know at the end of the day our answer is going to be negative. So in this case, our final volume is 21.0 liters, and our initial volume is 19.0 liters, which means our change in volume is 2.0 liters. We can now plug in. W equals negative pressure, 26.0 atmospheres, times change in volume, 2.0 liters. And mathematically we have a negative times a positive, so we know we're going to get work as negative. But again, if the system expands, okay, then that means the system did work, so therefore the system lost work, so we know the answer is going to be negative anyway. In this case, to two significant figures, because this is two significant figures, W equals negative 52 liter atmospheres. Liters times atmospheres. Now, I don't know if Alex will accept this answer, but if we were going to go on to calculate delta E, which is Q plus W, the Q is definitely very unlikely to be in liter atmospheres. It's going to be in joules or kilojoules. So we should get in the habit of converting liter atmospheres to joules or kilojoules. It turns out that 101.3 joules equals 1 liter atmosphere. So this is the relationship between joules and liter atmospheres. So starting with negative 52 liter atmospheres, we want to put our 1 liter atmosphere on the bottom because we want it to cancel out, and our 101.3 joules on the top. When you do this, the calculator will give us negative 5267.6 joules, which to two significant figures is technically negative 5,300 joules. But this isn't ideal and can be a little bit ambiguous, so this may not be the best answer. So you could write this as 5.3 times 10 to the 3 joules, or you could simply convert it to kilojoules by dividing it by 1,000, and what you would find out is probably the best answer, 5.3 kilojoules. So 5.3 kilojoules is exactly the same thing as 5,300 joules, but here the significant figures are not ambiguous. Here they a little bit are, so I would probably stick with this answer. Note that this should be negative because the work done is done by the system.